Yes.
So in relation to that root, when you have, for example, that one is cube root, right?
Mhm.
Whenever you have a different number, what is that exact term called for the number of the power of the root?
I mean, it's called an index.
Okay.
So this is the index of the radical. Um, in general, we just call it an nth root where n can be any number greater than 1.
Okay, thank you, sir.
Yeah, it's also considered to be a fractional power. And I'll give you some, I think later after class, I'll send you a formula sheet that has all the properties in case you don't remember them. The only thing I want to mention here before we do, I think we'll do number 8 first, but just remember any root, doesn't matter what it is. If you have x over y, some two numbers, some real numbers, you can always do these separately. This will be on the formula sheet that I will send you. You cube root the top, or nth root the top, nth root the bottom. Okay. So I'll send that to you in a little bit. There's a bunch of these types of properties. Okay. But let's do this one here. And I'll write them off as we use them as well, just so you have them next to your example. So let's do number 8. Okay. So number 8. So this is P2. Example 1. Problem 8. Let me see here. Okay. All right. So part A, let me put the instructions right here. Use the properties of radicals. Part A. Here, there's a couple properties you can use. They have a cube root raised to another power. They have a cube root of 7. Now, there's no way you can actually, yes.
Sir, I think it's 6.
Number 8.
Yes, on section A, number 8, and then there's A and B, and A it says 6.
Well,
They're randomly generated.
Yeah, everyone's will be different.
Okay.
Sometimes they're the same, but yeah, don't worry about the number. The example is the same, but different numbers. But thanks for watching out. Appreciate that. So there's a couple ways you can think of this. There's a property that says nth root of x, some real number x, that can be rewritten as nth root of x to the m, if you want to. Also, you should remember that any nth root of some real number can be rewritten as x to the 1 over n. So every radical or square root, cube root, whatever, is technically just a fractional power. So it's just 1/3 in this case. Okay. Alrighty. Also, let me give you one more. I think I could fit it right here. This is the same as x to the m divided by n. These are all the same. And then that's why the roots cancel, because of this. So in this case, you know how when you square a square root, they cancel out, right? Same thing for a cube and a cube root, and that's because of this property here. So when you apply the properties, even though we know the answer, technically this is the same as saying 7 to the 3rd power, 3rd root. So the root is always on the bottom, the power is always on top. So 3 over 3. So they cancel out, giving you just a 7 to the 1, which is a 7. Okay, so just reviewing all of our properties. So the class is going to assume you remember all your radicals, but we're going to go over them today a little bit just in case. Is there any questions on this idea so far?
I have a calculator question.
Sure. What's up?
Is there a way to raise the power for the index on the calculator?
Depends what calculator you got.
I have a FX 300.
Thanks. 300.
It's like a basic calculator. It's not a graphing or anything like that.
Let me look that up 1 second. It's the Casio, right?
Yes, FX 300 ES plus.
Yes, you can use the button with a power on it and use a fractional power, but you see the X with the square on top?
Yeah,
Right above it, you see the yellow writing has a
Yeah.
index. So if you
What-
hit shift and press that, it should do it for you.
when I do that, it becomes an X to the index.
You might have to type the number first and then do that. Did you try that already?
Let me try that right now. Yeah, same thing. It's the 8 and then to the index of X square root.
Well, you can always just use the 1/3 as a power instead. To just use the X to the square and just type in 1/3. But it should do it. I just don't know the which way to punch it into that particular machine.
Okay. Yeah, no problem. I'll try to figure that out.
But the answer is yes, it can do it. I just don't know
Okay.
how.
Okay.
Okay. Any other questions on example 1 or in general? I guess we could do part B. Part B looks harder. Okay. Part B. Is a cube root of 8x cubed. There's a couple of ways to do this. The properties that we should think about are these here. So nth root of something times something, 2 real numbers, can be done separately, just like the fraction. So you can apply your roots on each factor separately. So you can do the cube root on the 8 and then the cube root on the x cubed. And when you do that, it should be pretty obvious what your answer is going to be. So this works with any index, any number root. Okay. So right here, this would be cube root. If you separate them, of 8 times the cube root of x cubed. Now, as we said earlier, right, when they match up here, this is always going to happen. So we can skip that step if you want, or you can show this part. Doesn't really matter. Okay. You can rewrite this cube root or this 8 as a cube power here as a third power if you want to, and just show that these will cancel.
Sir, we can't really see that. I can't see that far down.
Sorry about that.
Thank you.
And at that point, it's pretty much it. The roots are gone, so you're left with 2x. You can do this a couple of different ways if you want. But as soon as you have a power that matches the index, they're just going to undo each other. They are inverses. Okay, so you could have rewritten this entire thing if you wanted to, like an alternate way for B. You could have said, you know what, I'm going to rewrite the whole thing. I wrote that weird. Rewrite this whole thing as 2x cubed, right? Using our algebra skills. These will cancel and gets you to the same place. So do it separately, together, doesn't matter because we're following the properties. Okay. Any questions on B, either approach? All right, let's move on then. The other thing they want you to go over, other than your basic properties, is do you know how to reduce your radicals? This is a very common one. Cube root is a little more annoying, but still doable. When you're trying to reduce a square root, you want to find numbers that are, you want to factor the number inside and look for squared numbers. As soon as you see that, just factor it, and then that part will be square rooted. You'll do something similar for the cube. You're going to look for cube numbers in here and see if there's a cubed factor and just break it apart. Okay, so let's do number 9. All right, example 2, problem 9. All right, part A says instructions, simplify. Right, yeah. So the square root of 12. So what I like to do, if it's a number that's really huge and you're not good at doing mental math, just divide this on your calculator. It doesn't matter. So basically just think of all the squared numbers, right? 4, 9, 16, etc. Obviously, 12 is pretty small, so you only have a couple of options. So divide by 4. So if it goes in evenly, then we're good. And 9 is too big. As you can see, 9 is not going to work. So what you end up doing is factor this guy into 4 times 3. So I was looking for a squared number. Square root of 4, right? You can separate this, or you can skip this step entirely. And remember that this becomes 2 and the 3 stays, because this is not a squared number. This is as best it's going to get. Square root of 4 gives you a 2. So 12 can be simplified into this. Okay. It's pretty much the gist of it. So just cycle through your squared numbers. So whenever you have a big number in here, just keep going. 4, 9, 16, 25, keep going. Okay. If you don't know them, then just look them up. What are the squared numbers? There's a list. If you need them, I'll send them to you. Just let me know. Cube of 250. So same idea. Think of cubed numbers. Most people don't have that many cube numbers memorized, which is fine. Who cares? I know for sure we got what? 125, 27. So stuff like that. And if you don't know, look up the list or just multiply it 3 times. I know 125 is going to go into 250, right? So that's what I'm going to choose. So cube root of 125 times 2. So the cube root of 125, or you can show the work. It's going to be 5 cube root of 2. As far as it's going to go. Any questions on this? This should be very familiar. So number 10 is the same type of stuff, except they have a fraction instead. So instead of just one single number, you're going to approach the top part separately and the bottom part separately. Although if you see the fraction reduce, do that first. There's a common, something in common with 16 and 27 or 32 and 49. Reduce it and then begin. Okay. But that's the same thing. So let's move on. 11 is different. Here,
I'm sorry,
yes.
sir. Did you do that cube root 125 on the calculator? Or was that just something?
That's something I remembered. Like I knew
Oh.
that this was a cube number, and I knew that
Okay.
went into 250.
I was just wondering if you did it
Uh,
on the computer, how, or
But yeah,
Okay.
5 times 5 times 5 is 125.
all right, I got it. Thanks.
But yeah, I mean, I don't expect you to have all the cube numbers memorized, but it helps. Like 27 is a common one. Those are the two I remember. 125, 27. The rest I don't. So don't feel bad. I'm hoping you know most of the squares though. I hope. Okay, number 11. Here we're basically adding like terms. So the rules for adding any kind of radical, right? Anything with this symbol, right? It's called a radical. They have to be exactly the same in order to add them. So just like terms, right? Like 3x plus 2x equals 5x because it's the same thing. So if these are the same, then you add them. Currently, you cannot add them because they're not the same. So the idea for number 11 is you reduce, just like we did the last example, and then see if you get something that can now combine. So reduce, and if you have like terms, combine them. If you don't, you just stop, leave it alone. That's all you're gonna do. Okay. So let's do 11. You guys okay on this page?
Yes, sir.
All right.
Yes.
Well, example 3. I'm just going to put simplifying because that's basically all we're doing. We're not solving for anything here. So 4 times the cube root of 128x cubed plus the cube root of 16x cubed. Okay. So these are cubes, by the way. All right. So same thing. Check if there's a cube inside 128. If you don't know the cubes, well, let's look them up. And it's no shame in that. All right. List of cubes. 8, 27, 64, 125. So those only two I remembered were these two. Well, of course, 8 is the obvious one, but after 8, I start to forget. But anyway, there's charts, right? For squares, cubes, and so forth. Yeah, anyway. So we had 128. So I'm thinking 64 is probably going to be the one we want, right? So let's use that. 16, well, I'm probably going to want to use the 8. Okay, so here we go. So 64 times 2 times x cubed plus the cube root of 8 times 2 is 16. So there it is. So I'm purposely factoring them into stuff that reduces. That's the whole, we're basically rigging the problem. Okay. All right. So at this point, The way I like to do it is just cube the parts that are able to reduce and just bring them outside. So cube root of 64, that's going to be what? Right, 4 times 4 is 16 times 4 is 64, right? So this is actually 4. The 2 is not going to come out, so that'll stay. Cube and cube will cancel, giving me an x. Everything else will stay inside. That's kind of how I do it in my head. If you don't want to do that, that's fine. You can factor them first and then just cancel the 3's. But does this make sense? Is that okay?
Yeah. Yes, sir.
It's supposed to be a 3. So cube root of 8. Cube root of x cubed. That 2 is going to stay. Okay. Simplify everything. 4 times 4 times x. 2 times x, well, that's just going to be itself. Now notice that it's the same type of root, right? So you can add these now. 16 plus 2. And that's it. So originally you could not add them because they were not the same. After you simplify, they turn out to be the same. Any questions on these steps? If you want an in-between step here, you could have written 4 cubed times 2 times x cubed for that first part. Plus, you don't have to. You can though. 2 cubed times 2 times x cubed for that second piece. Right, so all the cubes are going to cancel. So this 4 came out here. This x came out there. This 2 cubed came out here. That x cubed came out there. So however you want to think about it, doesn't matter to me. As long as your math is legit, you'll be fine. I don't care how you do it. Just show your work.
I have a question.
Yep.
Are we able to redo this? Because on that question, I got it right. I just forgot to put the X after the 18, so it marked me as wrong.
Yeah, you should have multiple tries.
Okay, cool.
I think it should be like try another or something like that somewhere.
Yeah, I don't see that. Maybe it's all the way at the bottom. Let me check. Oh, new randomization, is that?
Yeah, try that.
Okay.
Yeah, I think there's at least, I don't know if it's 3 or 5 tries per question. I forget. But yeah, you can do multiple tries.
Sir, I have a question.
Mm-hmm.
You want us to show our work, you want us to scan it in, correct?
For your exams, yes.
Okay, just for exams, not for homework.
Now for homework, I mean, I would recommend you do all your work so you get the practice, but I'm not gonna have you turn it in.
Okay, thank you.
Okay. All right. Anyway, does this make sense? Any questions on this?
I have a quick question, Professor.
Mm-hmm.
So the end result was 18x times the cube of 2. Prior to that, though, it was 16x to the cube of 2 plus 2x to the cube of 2. It's been about 10 years since I took high school algebra, so forgive me if it's obvious, but
No, it's okay. That's what you're here for.
Yeah. What happened to that second x to the cube of 2? Right. I would have assumed that it would have been like 18 plus 2x to the cube of 2. I feel like at one point one of those got dropped.
I guess think of it this way. I think it'll make more sense if you see it like this. 16x times something, and then you have 2 more. So these are the same things, right? 16 of these plus 2 more of these You agree that that should be 18, right?
Yes, sir.
So it's the same thing is happening here. It's 16x plus 2x. Because they're exactly the same, you just combine them. So it's like 16 apples plus 2 apples, 18 apples. Like, who cares what this is? It's just something, some item, some term. That makes sense?
I think so. Yes, sir. All right. So it's just, combining them doesn't necessarily make it like 2x to the cube of 2. They just kind of, as long as they're there.
Yeah, so yeah, you can't do anything with this, right? Because
Right.
we're just doing addition. So you have 16 of these things and 2 of these things.
Right.
16 plus 2, that's all we can do.
All right. Yes, sir.
If you were doing multiplication, then that's completely different. A bunch of stuff would happen.
Gotcha. All right. Thank you very much, Professor.
Mhm. But yeah, it does feel like we should do more, right? Okay, now let's move on. Well, we should do B just in case. Cube root of 125x minus cube root of 8x to the 4th. Okay, so the numbers are no big deal, right? Now we're trying to get used to that these are cube numbers. The 8 and the 125 are cubed. This x to the 4th is different though. So remember how in the last example, I think before this question, we were reducing by factoring out cubes or squares. So here's the same thing. You factor a cube out of the 4th, and that part will reduce. Okay, so let's show all of our work. This is 5 cubed x minus 3. 2 cubed is 8, right? X to the 4th, that's the same thing as x cubed times x. Do you agree? Right, don't forget.
Yes. Yes.
All right, don't forget what it means to be to the raised to the 4th power, right? So I know 3 of these are going to be cube rooted. Okay, so I purposely broke it up into these 2 pieces, these 2 factors, knowing that the cube will take care of anything with a 3 on it. Okay, so right here we'll end up with a 5, and then that cube root of x, that x stays inside the cube root. Over here, the 2 and the x are going to come out, leaving the cube root of x. Does that make sense? Is this step okay?
Yeah, so those threes cancel each other out in that 2 to the 3rd power and x to the 3rd power.
Yeah, exactly.
Just leaving the 1x.
Yeah, anything with that, anything that matches the index is going to cancel, and they come out without a power. So it's the same thing for like square root of 4, right? That's square root of 2 squared. So since it's a square root, they cancel. Same.
I've
Yeah,
never
we
seen
just-
it done that way. Yeah, that helps a lot though. Thanks.
Yeah, we don't think about it because square root is just something we memorized, but that's technically what's happening. A square root is a root 2. We just never write it. It's just understood to be there. So 4 is a 2 squared, which cancels. Same thing with 9, 16, whatever. So at this point, they have this, they have the same root, right? So you can combine them, but these are not the same term. So it's almost like you combine them. So you can think of this in two different ways. You can think of it as a factorization, or I'm just adding two things, but not really, like so. Right, these don't combine. So it just stays like this. So 5 minus 2x, I can subtract them together because they have the same root, but they don't combine together. Over here, they did, right? 16 plus 2 was 18. But if these were different, you would just have 16 plus 2 right here. Or let's say this was a, I don't know, 2x squared. This would become 16 plus 2x squared. But if it makes more sense to think it as a factorization, right? I'm factoring cube root of x out of both of them and putting it in front. That is equivalent. I don't care how you think about it. That's the same. Any questions about part B? I think factoring makes more sense to most people.
Yeah, I think it's good. Makes sense.
Okay. Well, let's move on. So 12 and 13 are asking you to rationalize. That just means get rid of the square root or get rid of the root at the bottom. Here we have a square root, here we have a cube root. So in order to get rid of a square root, you'd have to force the square. To get rid of a cube, you got to force a cube. That's all. Or complete the cube. Let's do that first one, just in case. You guys cool on this page? Might be able to fit it here, actually. All right, problem 12, just rationalize the problem. So in order to rationalize, you want to multiply by square root of 2 over square root of 2. This will force a square to happen at the bottom, right? You get, let me give you another rule. Square root of a times square root of b is the same as square root of a times b. You can multiply them together. So root 2 times root 2 is square root of 2 squared, which cancels, right? Gives us square root 2 over 2. So no more square root in the bottom, which is the same as 4, right? Anyway, so when you hear rationalize, they're telling you to get rid of that root. Okay. Now let's do something that has multiple terms. You guys cool on this page?
Yes, sir.
All right. Let's move on to example 5, problem 14. Get some marks on my, oh well. Rationalize. So 5 over square root of 35 minus 5. Do you guys remember what conjugate pairs are?
I don't remember.
It's like the opposite, right? Like the square root of 5 plus 5.
Yeah. So essentially it's the same thing, but opposite sign, right? So A plus B times A minus B, these are conjugate pairs. Conjugate pairs. So in order to get rid of this, the procedure is you multiply by the conjugate of the denominator on top and bottom. So the square root of 35 plus 5 over square root of 35 plus 5. So you're essentially forcing a difference of squares. So this is a special product that will always equal to the first term squared minus the second term squared. So on the top, well, it's just going to be 5 times that garbage. Over. If we use the formula, it'll be the first term squared minus the second term squared. So the bottom will become 35 minus 25. No more square roots. The top will just have to distribute the 5. It's the ugliest 5 ever. Okay, and that's pretty much it. The bottom will simplify into a 10. We could reduce this a little bit. There is a common factor on the top and on the bottom, right? You see how we can factor 5 out of here? If we leave it as 5 instead of multiplying like we did up here,
Yes.
we could have canceled it with the 10. So we should not have multiplied till the end. Oh well. Because 10 is 2 times 5. So I added extra steps for no reason.
How did you get that second step, that square root of 35 squared minus 5 squared?
Oh, this is from here to here.
Yeah, yes.
So if you multiply all this out, like if you were to actually FOIL this out, or however you want to think about it, distribute. Like this is basically the formula right here. A plus B times A minus B will always be the first term A squared minus the second term B squared. If you multiply everything else, the middle terms will cancel, leaving you only with this. So you might as well just use this formula. If you forget the formula, you can always multiply it like normal. But that's how I got this. I don't have
Got it.
space. Let me put it down here. Any other questions on example 5?
So is that just a conjugate formula? Is that just something you can use all the time for that?
Yeah, you can always multiply by whatever you want on top and bottom as long as it's not a 0. So, but if you choose a conjugate, it will multiply as a difference of squares every time. So if you need 2 squared numbers, you can use this if you have 2 terms on the bottom.
Okay, I see.
So right here, right, you would do the same thing. You would multiply by root 5 minus root 6 on the top and the bottom. What would you multiply here on 16?
by the numerator with a negative.
Yeah, it'd be the same thing, right? This is
Yeah,
screwed.
to both the top and the bottom.
It doesn't matter where it's at, just multiply by that conjugate. That's it. Okay. Let's move on to something different, although that might be pretty much the gist of all this. I'm gonna leave these to you, but just to give you a hint, on 17 through 20, they're using a definition. So in the book or the notes, there's a radical form and then rational exponent form to just use that definition or the formula. Remember that a root is a fraction, right? So third root is 1/3 power. Here you're doing the same thing, but you got to simplify first. So simplify like we were doing before. So change this to a fraction and multiply, and then that'll be 9/2. Let's move on to something different. These guys look more difficult here. Number 21. You guys cool in the last example?
Yes, sir.
Okay, so let me know if I go too fast or if something doesn't make any sense, just tell me. It's no big deal. So 9 to the -3/2. So there's a couple ways you can do this, but you need to have your properties. You can write down a couple for you. X to the negative power is the same as 1/x to that power. So you can flip that over and then apply the power. Also, don't forget that I wrote earlier, x to the n, m/n is equal to the nth root of x to the m, which is equal to the nth root of x whole thing to the m. So use whatever you think is useful. Doesn't matter which one you use. Whatever gets the work done, right? Whatever solves the problem. Okay. So let's go ahead and use this first. So that'll be actually, let me write that better. So if I change it to a fraction, this becomes a positive power. Now we can, once it's in this form, you can change it to one of these. I think this guy is the better one instead of this one. Because I can see that 9 is a squared number, right? So it's better to apply the root first, the square root, and then apply the power. So what this is saying here is you can either apply the root first and then raise it to the power, or apply the power and then raise it and then do the root. So use whatever is going to help you more. That's your decision. Most of the time, the last one's better. Most of the time. So what we can do is square root 1/9 cubed. So that'll be 1/2. Oops, sorry, 1/3, right? Cubed. So if I square root of 1, that's a 1. Square root of 9, that's a 3. Now cube it. 1 cubed is 1. 3 cubed. Let's show our work this time. 1 cubed over 3 cubed. It's going to be 1/27, right? If you want an in-between step here, basically what I did was cube root the 1, cube root the, keep saying cube. It should have been a square. Damn it. That's how I got 3 and 1. Any issues with this problem?
No, sir.
All right. Give me a second. Okay. Sorry about that. Anyways, you guys are good, right? Do you see how you would do this one? Part B. So I'm going to move on to 22. Do you want to do part B?
I think that
Yes.
one for us is easy because we can also watch. I think they give us some video on the actual question.
Yeah, they do it on most of them.
All right. Let's move on to 22 then. This one looked kind of weird. Although it's not too bad. It just looks weird. All right. Be the last one, then we'll move on to another section. Then we'll take a break too. Oh, sorry, I didn't hear. My bad. Okay. So on this one is basically the original rule of exponent. If you have the same base and you multiply them, you're going to add them together, right? I'm hoping everyone remembers this. This is one of the first rules you learn in exponents. And if not, it's okay. Just let me know. Treat this as your same base. This is like your giant X here, X. Okay. So since they are the same, you're just going to add the 1/3 plus 2/3. One-third plus 2/3. Does that make sense? That's all you're going to do. 1/3 plus 2/3 is 3/3, which is a 1. So that's it. You do the same thing here. 1/3 plus a negative 4/3. So just deal with the negative and you'll be good. Same question. 23 is something we've already done. You simplify and then see if you can add them together. Simplify and then see if they are the same. But I think that's enough radicals for today. Let's do some other section. All right, so it's, let's see here. Okay, let's take about 10-minute break. Come back at 7:10. We'll start P3.
Oh, yes, sir.
All right.
Bye. Sounds good.
All right, see you in a bit. As you can see, it's just multiplying your polynomials. Stuff I'm sure you remember doing, but just in case, we'll do a couple here and there. We'll do number 1 and go from there.
Excuse me, sir.
Mhm.
So just as a question, when we do quizzes or tests, are these reflective off of these homeworks or?
Yeah, it'll be the same topics, but the first few sections are review.
Okay,
So like the actual first section doesn't start till section 1.1.
okay, got it.
So if it seems very familiar, then great. If it's not, then this is the time to review, right?
Sir, will the tests be like timed? Like
Yeah.
certain numbers? Was it like a minute a question or?
I mean, I'm pretty flexible about time. I hadn't really decided. I need to check when we get there, but if you guys need extra time, it's not a big deal. Just remind me before test time.
Okay, thank you, sir.
Currently, I'm not sure what it's set at. It might be like 2 hours per test or something, but I gotta check. If you want more, it's fine with me. Just not a ridiculous amount, but okay. So here, just multiply your 3x on every single term. This is the same thing as saying 3x times x squared plus 3x times negative 3x plus 3x times the 1. So just distribute on each part. All right. So 3 times x squared. So you're only going to combine the x's here. This is a 1 power. So 1 plus 2. 3 just stays there. 1 plus 2. Over here, you have a constant and a x term. So 3 times negative 3 will be a negative 9. So right here, just put the minus. X times x will be x 1 plus 1. 3x times 1, of course, is just itself. So this will be 3x cubed minus 9x squared plus 3x. Is there any questions on any of these steps? Okay. So not too bad, right? I'm sure most of you remember, so just bear with me. Just gotta go over it just in case. And don't feel bad if you forgot. This is the time to practice. Number 2 is the same deal here. Number 3 is a little different. Just notice that you have a minus, right? So -5 times the positive will give you, so this answer, right, be -15, -5 times 3. Z times the z gives you the z squared. So 1 plus 1, right? So that's where this comes from. And then -5z times the -1 gives you a positive. So there's nothing really to do here. Just watch your signs and you'll be good. Okay. Let's move on to something different. I'll leave that to you. Number 6 is slightly different. Yeah, let's do 6. Problem 6. There's a few ways you can think about this. I think you can do a foil. You can think of it as that. I think nowadays they call it a box method or something. Do it however you want. I don't care. Just multiply it out. Okay, 4x minus 7 times 9x plus 1. The way I like to think about it is basically that I'm doing 4x times this entire thing. You don't have to do it this way. I just like to do this. Minus 7 times that whole thing. And then just do it as a distribution. That way I won't mess anything up. This kind of keeps me organized. That's the only reason I do this. Especially if you have like 3 or 4 terms inside. This keeps me straight and I won't make a mistake. So 4 times 9, x times x. That's 36, right? X squared. 4x times the 1. It's 4x. These are -7 times each of these. So that'll be minus 7 times 9. 63, right? I don't like numbers anymore, so just double check me. -7 times the 1. Okay. Combine like terms if there are any. 4 minus the 63. That'll be negative, right? 59. Okay. Any questions on the multiplication? So if you do it this way, it should be safer, keep you from doing mistakes. If you prefer a box method or foil, go for it. But notice right here, when you have like 3 terms, it might be better to do it the way I did it, because you'll have x squared times 3 terms, negative x times 3 terms, 3 times 3 terms. That'll be easier to, keep everything together. Anyway, let's move on. These are special products right here. This is basically the formula that I wrote earlier. A minus B times A plus B is always going to be, doesn't matter what order, the difference of squares, right? Something squared minus the other thing squared. So x squared minus 9 squared. X squared minus 9 squared. They're just applying the formula. Does that make sense? Same thing here. Notice how it's a difference of squares again, a conjugate pair. So square the first part, according to the formula up above, minus the other term squared. And that's your answer. You don't have to FOIL, multiply, whatever. Just use this formula and you'll be done. Does that make sense? Any questions on 10 or 11?
No, sir.
Okay. Here we have a binomial expansion. So this formula is for all of these. If you have a 2, if you're scoring 2 terms, right, it's always going to be this specific trinomial. So I don't care what it is, a and b squared. This will always be equal to a squared plus 2ab plus b squared. So our a and b here is the 2x, right? It's this guy here. And 3. So if you square this, just square the first term.
Yeah, I have a question.
What's up?
Why does the PowerPoint use the U plus B and here you use A plus B?
Say that one more time.
The PowerPoint uses U plus B, the B is in Victor, and then you use here A plus B.
Well, it doesn't matter. You can use X and W if you want. It's all the same.
Okay.
I use A and B just because they look different. U and V's look the same when I write them, but it doesn't matter what you use. Use either one, whatever you like. Okay. So A and B is right there, or U and V if you prefer. Square the first one plus 2 times both of them. So 2 times the first term times the second term. Excuse me. And then square the last term. That's where this comes from. 2x squared is 4x squared. 2 times 2 is 4 times 3 is 12. That's where the 12 comes from. 3 squared is the 9. Okay. That makes sense. We're just following this formula. Here's the A, the B, oops, messed that up. The B squared, A squared, and the random 2. Is that straightforward?
Yes.
Okay. So do the same thing here. Notice how they have a minus instead. Yeah, it's the same thing. You can either incorporate into the formula or use a different formula. You can use a minus version if you want, but it's really just an extension of the original. But I'll write it out for you just in case. It's a squared minus 2ab. It's the only difference. So you just plug in your a here and your b term, and you'll be good. Anyway. Any questions on this idea, these special products here? And I'll give you a sheet with all these formulas at some point. Yeah, that's pretty much it. There's also a cubic formula, which I'll give it to you as well. There's a sum of cubes, difference of cubes, a square formula we just did. And then we have the difference of squares. So there's 3, or actually 4 formulas that you should have either on a formula card, or if you have it memorized, cool, that's great too. But that's all you need for this section is, do you know how to distribute powers and variables? Do you know how to deal with the exponents, distribute a negative sign? And do you know how to use these special products, these formulas? That's all you need to do in P3. Are there any issues with those ideas?
No.
No, not at the moment.
Okay, just let me know if, and I'll give you that sheet after class as well. I'll send you one.
Sir, will you be doing tests after every chapter, or every 2 or 3 chapters?
I decided to combine unit 1 and unit 2 into one exam. So once you finish unit 2, that's when the exam will be coming. I think I already put a date on it. We'll talk about it in a second.
Okay.
We'll talk about after P4. I think we have time for P4. It's getting dark in here. Okay, let me go ahead and write the formulas down here just in case. A plus b squared is this formula. I'm going to scan this to you later. Number 2, and it's also in the PowerPoint, like somebody said. You have a conjugate pair, you're always going to get this. And then there's the difference of cubes and the sum of cubes. I always forget the sign order. Let me look it up so I don't mess you up. Give me a second. Sum and difference of cubes. There it is. Oh, actually, I wrote that wrong. That's a binomial expansion, not a difference of cubes. Okay. You have the first term cubed minus the second term cubed. Just in case. This might be the next section, but I'm just writing it now just in case. I don't know why I use lowercase, but whatever. Inconsistent. Oops, sorry about that. Anyway. Let's move on. P4. P4 is something you've done quite a bit. It's factoring. So all the common factoring techniques. Okay. We'll do a brief overview of each of as many as we can. The first technique will be to just the GCF. Find a common factor in all your terms and pull it out. So number 3, 4, and 5 is just factoring a common term, common factor. Okay, after that, you're going to do the difference of squares, which we just started talking about. Apply the formula. You may need to prepare it and do a step before, and then apply the formula. Okay. And then we have the trinomial factorizations, which we'll go over. Here's a sum and difference of cubes. So that's just using that formula I gave you. These will be trial and error. Number 13. 14 and 15 and 16, you could do trial and error, but it is kind of annoying. I recommend doing the AC method, which I'll show you in just a second. If you have 4 terms, you want to try grouping, which is basically a more complicated version of GCF. These are things that you've done before, all of them. But let's go over it again, just in case.
So for the homework, we just put the answer, we don't show the steps.
No, you're not required to show work for the homework, but I highly recommend you do the work yourself.
Okay.
Just get in the habit of writing it out, showing your steps, because that's going to be required on your exam. Factor out the common factor. In other words, we're doing GCF, right? Greatest common factor. 3x cubed minus 9x. So what is the biggest number that I can factor out from both of these terms?
3.
It's going to be 3, right?
And X.
So at most, they have 3 in common and a single x, right? You said? Okay. So those of you that are very rusty, think of this as division. Right, I'm dividing this factor out. When you factor something out, you're removing the factor. So once you do that, this becomes x squared minus 3. All right, so I'm factoring out 3 from both and an x from both. You don't have to show this step, but it's technically what's happening. Is there any questions on number 1?
No.
No, sir.
Okay, let's do one with 3 terms and one we'll do something else. On this one, they all have a 3 in common, and at most 1 single z in common. So that's why I chose, wrote that z all stupid. That's why I chose 3z as my GCF. So basically what you want to do when you start these is identify the GCF and then pull it out. Once you start factoring it, you're going to be dividing into each term by that GCF. If you choose the wrong one, that means that after that first step, right, after we do this step, you may have something still in common here with these two terms. So just do it again. So if you miss it, just add an extra step and remove that extra factor. If you get it all at once, great. Right? So divide this by 3z, this by 3z, this by 3z. So z squared divided by z reduces it by a power of 1. These 3's are gone. 6z divided by 3z, these z's are gone. 6 divided by 3 is a 2. Oops, I think I made a mistake. This should have been cubed. This is squared. Cubed. Let me redo that first part right here. So if it is cubed, then this will become a square. This will become 2z. This will become a 3. Okay. Do one more GCF, then we're moving on. This one is different. Is the only reason I want to do it. So in this guy here, treat the x minus 5 as some common factor, like a w or something. You're going to pull out this w out in front. Or so factor this out. That would give me, I'm putting a bracket just for emphasis. You don't have to. Oops. That's an accident. I'm only factoring x minus 5, not the 3x. So I'll be left with a 3x in here plus a 2. So these were factored out in front. Okay. So pretend if you had a 3x w plus 2w, you would factor out w, right? That's essentially what we did here. It's the same thing. Like, who cares? It's some term. Any questions on 1, 2, or 3?
No.
All right. The next 3 are difference of squares. So 6, 7, 8 is the same thing. They're just, slightly different. It's the same type of question. They just look different. So we're going to need the difference of squares formula. Just make sure you set it up first. Okay. You guys cool on this page? I'm going to turn the page.
Yes, sir.
Okay, yeah.
Yeah, wait a second.
Yeah.
Oh, okay. Sorry. So we're using this formula to factor, not to multiply this time. So we're doing the opposite. So we have 16y squared minus 49. rewrite this as a square minus a square. 4 squared is 16. Y squared, obviously, is y squared. 7 squared is 49. Once it's in this form, you can just straight up apply your formula. The a is this term. This is my a and b. Okay. So that would become a plus b times a minus b. It doesn't matter which way you do it. Who cares? It'll be the same, right? A minus b or a plus b can go first. But just make sure you factor if you need to at first. Any questions on number 4?
No.
No.
Okay. Problem 7, same question. The difference of squares okay. Here you got to factor a GCF first before you attempt to do difference of squares. What is the common factor?
Nine, 18.
And they're both even, right? If I factor out a 2, what am I going to get? Since they're even, we know for sure that 2 works.
49 for the 98.
Right,
And
49.
then, 9 on the
9.
second.
Yeah, 9. Now notice we got squares, right? That's what we wanted. Now we can apply the difference of squares. The 2, we're just going to ignore it. It makes no difference anymore. So rewrite the 49 and the 9z. And then apply your formula. So it'll be a plus b, right? A minus b. Nothing crazy. Any questions on any of the steps?
No.
And even if it feels super easy, make sure you take the time to practice and write it out. Because it's not the same until you do it yourself. Number 8, it's the same thing, but you're gonna have to do it twice. I'll leave that to you. Let's move on to something different. Number 9, 10, and 11. Actually, no, just 9 and 10 are perfect squared trinomials. Let's do 9, I guess. 25z squared minus 70z plus 49. So the hint that it is a perfect square is if you see that the first term is a square and the last term is a square, there's a good chance that this is a perfect square. But 90% of the time, if you see that, it's going to be that type. And all perfect square means if you have two terms being squared, right, the binomial formula, you'll get a squared plus 2ab plus b squared. So we have these two right here, right? We just got to verify, do we got 2ab or no? And if we do, then cool. So this will be 5z minus 70z plus 7 squared. So I got my a squared and my b squared. So if I multiply a and b together and double it, do I get 70? Right? A is 5z. B is 7. What is 2ab?
It's 2 times 52 times 7.
Besides
Six
z.
times 5 times
Oh,
7.
Z, sorry. Let's see.
Yes, that's my bad.
10Z plus 14.
Close.
Or you have
See.
to do all together.
Yeah, so 2 times
Okay.
5 is 10. 10 times 7. Right.
70Z.
And that's what they got, right?
Okay.
So this verifies that it is in fact perfect square. But they told us, so we can jump to the conclusion. But if they don't tell us, we gotta kind of check. But once we know that it's always gonna be 5z plus 7. So technically you can go straight to here. So you do the same thing for 10 right here. Right. Rewrite that first term as a 3u squared. And then we got that middle stuff here, 12u v plus 2v squared. So this would be your a and your b. See what I mean? Any questions on this idea? You guys comfortable using this formula?
Yeah. So that's gonna be 5z plus 7 square, or is
Yeah.
that supposed to be 5z
five.
minus 7?
Oh, you're right. Yeah, should be minus. Good catch. So this is the plus version. The minus would be this one. The one we wrote earlier. There we go.
Okay,
Okay.
thank you.
Yeah. All right. These two are just cube formulas, the ones I gave you earlier. Change it to a cube minus a cube and then apply your formula. Change this to a cube plus a cube and then apply this formula. Let's go ahead and let's do one of them, I guess. Let's do the 12. It looks harder. Guys okay on this page?
Yes.
Oops. 27. I'm gonna use X because my T's look like pluses. Okay. So 343 is a cube. It's gonna be, what is, how do we get a cube?
So what was the question?
What is 343 as a cube?
Oh, 340.
7.
Yeah, it's gonna be 7. So this will be 3 x cubed plus 7 cubed, because 3 times 3 times 3 is 27. 7 times 7 times 7 is 343. Once you have it in this form, apply your formula. That's just, we have to stop after this guy because we're out of time. But the formula will be 3x plus 7 times 3x squared minus 3x times 7 plus 7 squared. That's for the sum of cubes that I gave you in the other, at the end of the last section. So the answer is 9x squared minus 21x, yeah, plus 49. Sum of cubes that I used here. Is this. Yeah. All right. Well, we'll stop here. If you guys have any questions, feel free to stay after. And if not, I'll see you on Thursday.
Thank you, sir.
Yeah, see you later.
So do you teach only